right? For making speaker point of view, do you want to make a speaker like a monopole or dipole? Monopole, because speaker means you generate the sound. You don't want that sound to decay rapidly, right? That is not speaker, that is noise control method. Right? So for speaker point of view, you want to make a monopole. Right? For noise control point of view, you want to make it quadrupole because it decays fast. Right? So that is the basic idea of control noise in space. How you control noise? Make a quadrupole or octupole. How to do it? There is a noise source. You put some structure that would make sound field more likely dipole, quadrupole, or octupole. And for turbulent fluid, it behaves like a quadrupole. For the drum, it oscillates like this. Not like this, it oscillates like this, so it is basically similar with dipole. Because dipole means that has different phase, means that when it expands, this one contracts, and this one expands, this one contracts. Right? Monopole is omnidirectionally contract, omnidirectionally expand, omnidirectionally contract. And that has this kind of behavior. But quadrupole, dipole is the two monopole together, but different phase, meaning that when I expand this one contract. Expand this one contract. Right? This is similar with the drum that has it expand, and this side will expand, and this side of air will contract. When it moves this way, this side of air will expand, and this side of air contract. So it behaves as if this is dipole. Hey, Professor, the drum has a finer size. Of course, yes, it has a finer size. But if the size is much smaller than wavelength, then it behaves like a monopole or dipole. Don't worry about the size, because we always see the size with respect to wavelength. Right? Hey, Professor, guitar has this size. How can you regard a guitar as a monopole or dipole? Hey, guitar is this size and this. This is 1 meter. If I'm concerned about wavelength, which is bigger than wavelength, much bigger than guitar size, it's monopole. Right? So, the seeing the frequency or size with respect to period or frequency or because we are measuring everything with respect to KR and KL. Okay? So, this summarized today. Everything is related with KR. Far field, near field. and a complex notation of intensity, which is headache. But you can use this 1/2 real part of P multiplied U conjugate. That is average intensity. And I hope you can understand that. Okay? But I promise you that in the midterm examination, I will not make the problem that requires to derive those things. But I want you to have experience to derive these things during the homework. Okay? But in the midterm examination, I will ask you, is it correct or wrong? For example, okay, this is a pressure in complex form, and this is a velocity in complex form, and the mean intensity would be this one multiplied by this, and take a real part, that is mean intensity. Is it correct or wrong? That kind of question would be the strong candidate of midterm examination. So you don't have to, so you can bring your text, because I will make a problem that is not, that does not appear in the text. Okay. But if you need to look at some detailed derivation, then you can look at it, because derivation means that when you have a time, you can take a derivation. Of course, you can make an error, but when you have a time, somebody can make a right derivation within 1 hour. Somebody can make a right derivation maybe using 1 week, maybe never achieve the right derivation in your lifetime, but okay, it's just a matter of time, like j minus j, more things like the cosine, sine. You can make an error, but I want you to have a right physical interpretation. Okay? That's the thing I have been emphasizing throughout this lecture. Now, please read carefully chapter 2, including appendix. Okay? And enjoy your homework.